Okay, I'm going to start to section 11.9 in this video, which is representing functions as a power series. So a lot of the directions here in the section are going to be where you're going to find a power series representation for each function and then determine the radius and the interval of convergence. Okay, you'll see that, and like for most of the problems in this section, you're going to be doing that. Okay. So here's one example. Suppose that I have the function f of x equals 4 divided by 2 plus x. What does this look like as a power series? Okay, well, I know that for a geometric series, the sum is n equals 0 to infinity of x to the n. That is 1 divided by 1 minus x. So a is 1, r is x. And this is for when the absolute value of x is less than 1, this series will converge. Okay? And when the absolute value of x is 1 or more, I know it diverges, and so I wouldn't get this formula, right? I get infinity. Okay? So the goal here in some of these problems is going to be to rewrite this guy in terms of a geometric series. So a divided by 1 minus r. I need a 1 minus, and then whatever the r value is. Okay? So that's what I'm trying to do here to start. Okay? We need a 1 minus in the denominator. Okay? So if I multiply the top and bottom by 1/2, 1/2 times 4 is 2. 2 plus x times 1/2, that's 1 plus x over 2. Okay, again, I'm trying to get this in the form a divided by 1 minus r. 1 plus x over 2, that's the same thing as 1 minus a negative x over 2, right? So now I'm in the form a divided by 1 minus r. The a value is 2. The r value is negative x over 2. So when I write this as a series representation, I have the summation as n equals 0 to infinity. Okay, so a times r to the n if I'm starting at 0. If I'm starting at 1, that's okay, but I just need to make sure I'm in the right form. It'd be a times r to the n minus 1. The a value is 2, and the r value is negative x over 2. Okay, so and now when I get this in the summation notation, like it's common that to simplify, and like anything else, you simplify things as far as you can go. Okay, so you're going to have let's see, you got negative 1 to the n, and then 2 divided by 2 to the n. Let's see, I'm going to, when I subtract the powers, 2 to the first divided by 2 to the n, that'd be 2 to the n minus 1 in the denominator. And then x to the n up top. Okay, so this here would be as simplified as we can get it. Okay, and that'd be my answer. That's the power series representation for this guy here. So f of x equals 4 divided by 2 plus x, and the summation as n equals 0 to infinity of negative 1 to the n times x to the n divided by 2 to the n minus 1, that means the same thing. These are both the same thing. Okay? Now, we want to find the radius and the interval of convergence. Okay? So, well, let's see. I'm using a geometric series. Okay, so what I know about convergence for a geometric, if the absolute value of r is less than 1, you're going to converge. And if the absolute value of r is 1 or more, you're going to diverge. Okay, so r is negative x over 2, or that's what we used when we went to the power series representation. The absolute value of negative x over 2 less than 1 means that the absolute value of x over 2 is less than 1. And so if I multiply both sides of this by 2, the absolute value of x is less than 2. Okay, so x would be between negative 2 and positive 2. the radius is half the interval. The interval is -2 to 2. I just said that, right? The radius is half the interval. Okay? Now, question here. So in the last section, we were checking the endpoints, right? Why am I not doing that here? Like, shouldn't I be plugging in -2 and 2 and checking that? No. So in the last section, the reason why we were checking the endpoints is because we were using the ratio test. This is a totally different test, right? This is a geometric series. And I know that you're going to converge when the absolute value of r is less than 1. And you're going to diverge if the absolute value of r is greater than or equal to 1. So I can check the endpoints if I want to. That'd be a waste of time, though, because I'm not including either one of these. Okay? Let's take a look at another example here. So what if I had the function f of x equals 1 divided by 1 plus x squared? What does that look like as a power series? Okay, well, I need to get this into the form a divided by 1 minus r. Okay, well, 1 plus x squared, that's the same as 1 minus a negative x squared. So the a value is 1, and the r value is negative x squared. So go to the power series representation now. You have the summation as n equals 0 to infinity of a times r to the n. Okay, a is 1. R is negative x squared. And bring that to the nth power. And then simplify this. You know, again, for everything that we're doing here, simplify things as far as possible. Like I have people who would circle this and, leave something that's completely unsimplified. Don't do that. Don't do that, okay? So let's see, we're going to have negative 1 to the n times x to the 2n as the sequence part inside the sum. Okay, so my answer will be the summation as n equals 0 to infinity of negative 1 to the n times x to the 2n. Okay, so what is the radius in the interval of convergence for this series? And again, this series and this function mean the same thing. Okay, it's just how you're writing it. Okay. Well, if the absolute value of r is less than 1, you're going to have a convergent series, right? Again, we're using a geometric series here to get this result. So the absolute value of negative x squared, the same as the absolute value of x squared. And x squared is already going to be a non-negative number, so I can lose the absolute value bars there. You got x squared less than 1. That means that x is less than 1 and x is greater than negative 1 when I take the square root of both sides there. So the interval would be the interval negative 1 to 1, and the radius is half of this interval length. The interval length is 2, right? Half of 2 is 1. Okay, now again, I don't need to check the endpoints because I'm not using the ratio test. If I were doing anything with the ratio test, then I must check the endpoints. Okay, that was in the last section there. Okay, don't get these two tests confused. Some students do that. Okay, don't do that. So we're using a geometric series. Okay, let's try another one here. So what if we had the function f of x equals x divided by 2x squared plus 1. What does that function look like as a geometric series? Okay, well, again, I'm trying to get this in the form a divided by 1 minus r. Okay, and the goal is to get a 1 minus leading off in the denominator. So let's see if I bring out the x. So I got x times 1 divided by 2x squared plus 1, that's the same as 1 plus 2x squared, which is also the same as 1 minus a negative 2x squared. Okay, so I've got x out in front of this summation. The a value is 1, and the r value is negative 2x squared. So a times r to the n. if I'm starting at 0, which I am. Okay, and then simplify this. So I'm looking at the summation as n equals 0 to infinity of negative 1 to the n times 2 to the n times x to the 2n, but then I'm bringing in the x from outside there. So I got x to the 2n times x, that's the same as x to the 2n plus 1. Okay, and this would be my answer. Okay, this is the power series representation for this function. Again, these both mean the same thing. Okay, and we'll see, you know, one big reason for representing power series as functions is because sometimes when you integrate a function, you can get the answer in one line of work. Whereas if you stayed in, you know, this form, maybe you get the answer in 3 pages of work. Okay, which can be brutal. Okay, we'll look at an example of that later on in the section. So let's see. I need to know the radius and the interval of convergence. So the radius r is negative 2x squared. Okay, the absolute value of negative 2x squared is less than 1. Means that I'm going to converge. Okay. The absolute value of negative 2 is 2. And if I divide both sides by 2, let's see, the absolute value of x squared would be less than 1/2. And if I take the square root of both sides, and x squared is already a positive, right? So I can lose the absolute value bars there if I want. But the absolute value of x would be less than 1 divided by the square root of 2. That means that negative 1 divided by the square root of 2 would be less than x, which is less than 1 divided by the square root of 2. Okay, so the interval will be negative 1 over root 2 to 1 over root 2. And I got parentheses at both ends, right? I'm not including any endpoints here, right? Because this is a geometric series. And the radius is 1 over root 2. Okay. Why don't we go ahead and stop the video right here, and I'll pick up with this example in the next video there. Okay. And in the next video, we'll take a look at integrating series and differentiating series, and how we can build other series from that. So, okay. We'll go ahead and stop the video right here, though.